Hello and welcome back to Lab. Today we're going to take a look at how to use Google's ADK framework to build a real-time document search assistant that lets users upload PDF files, ask a question by real-time live voice interactions with source citations. And the most important is the development is very simple. So here's the thing, Google just released two tools that make building this kind of system way simpler than before. First is the file search tool, which is a fully managed RAG system where you just upload documents and it handles trunking, embeddings, and retrieval automatically. Second is the ADK framework and its advanced web UI component, which is a built-in interface that gives you chat in text, voice interaction, camera interaction, file uploads, and more options with debugging tools that give you free of writing any front-end code. So today I'm going to show you how to combine these tools to build a production-ready RAG assistant. We will start with a basic agent, add file upload handling, integrate document search, and finish with a voice interaction on that document. By the end, you will have a system where users can upload a PDF, click the microphone, and ask like what's in the document questions, all in about 500 lines of Python. Before we get started, I want you to see the live demo first. Okay, let's see the live demo. This is the interface from the ADK's built-in web UI. So we don't need to do any development on that. We just focus on the backend. So here you can see we have a RAG agent, which is the name of our folder. So actually in that folder, we have several agents that I will describe later. So here, the first thing we need to do is to upload the one file and use that file to do the voice interaction. So first, let's upload a local file. I will choose a local file from the internet called Run a Guide for the New York City Marathon game this year. So I want to ask something about this marathon day. So let's upload immediately. Okay, the agent said, okay, I will start by checking the uploaded files, and it will list all the uploaded files in the system. So I see that the upload document PDF has already been indexed, so you can now ask a question about it. So this is the cost saving strategy that every time I upload a PDF file, it will check if it's already indexed and upload to the Gemini storage. If so, it will just use that existing index for the interaction. Now I'm going to ask something in voice speech about this marathon game. Let's press the microphone button.
Okay, great. What questions do you have about the uploaded document?
So can you tell me the overall summary of this document?
Okay, so the uploaded document is a runner's guide for the TCS New York City Marathon. It covers important info like race numbers, what to bring, the start and finish details, and post-race activities. It mentions that Tata Consultancy Services is the title sponsor and highlights the route through all 5 boroughs, starting in Staten Island and ending in Central Park. The guide also talks about things like security, transportation, and where to pick up your bag after the race. You can find all this information in uploaded_document.pdf.
So can you describe the entire route of this game?
Okay, the marathon route goes through all 5 boroughs of New York City. It kicks off in Staten Island at the foot of the Verrazano Narrows Bridge, then goes through Brooklyn, Queens, and the Bronx before wrapping up in Manhattan's Central Park. This information is in uploaded_document.pdf.
Good. So if I'm the runner of this game, when and where should I be ready at that day?
Okay, if you're running the TCS New York City Marathon, you need to head to Fort Wadsworth on Staten Island, which is the starting area. As for when, there's a start timeline, and travel times vary. For example, the Midtown Manhattan bus takes about 90 minutes, and the New Jersey bus takes about 60 minutes, not including security. Remember that only runners displaying their race number are allowed in the starting area, and everyone goes through security. You can find more details in the uploaded_document.pdf.
Seems all the workflow has been working. We will move to the next stage to explain what happened inside this backend. And also you can see the trace of the function call. The events happened during the conversation, the historical sessions that we have created. Okay, so before we talk about the development, first let me show you what file search does. So this is the newly released by Google Gemini API, which is managed a RAG pipeline built into the Gemini model framework. So by using the API, you can create, store, upload documents, and it handles everything under the hood, including the trunking, embeddings with Gemini embedding 001, embedding model, and vector search, and including retrieval. So all that in one box. The pricing model is interesting. The storage is free. Query time embedding are free. You only pay once when you first index a file. That is 0.15 per million tokens. And if you are looking at their file search document, you will find the code is very simple when you need to upload to file search store. When you importing files or add some trunking configurations and file search in the stores. These are very simple, just a few lines of code. Now let's talk about the ADK web UI things. So inside of the ADK, which called Agent Development Kit, you can define an agent, run the web, and you get a full interface of the text, chat, voice streaming, video import, file uploads, session state viewer, and a trace debugger. If you want to try this immediately, you can go to its document to see the quick get started. Make sure you pipe install the Google ADK, and you can create a new project by code ADK create. Let's try real quick. Inside of my text folder, ADK create my project. So it will ask you which model you are going to use for the root agent. I choose one, Gemini 2.5 Flash, and I choose one for Google AI models. And I'm going to input a fake API key. And now it has been created. Let's check in the text folder. There is my project folder, including an agent.py. It creates a very, very simple agent without any specific function. And .env for contain your secret and API key for this project. Okay, if we have that under the project folder, we can now run ADK web. Oh, there's another previous project has been running, so I will close it. Now I open this one again. Okay, it's running, and now the local web page. This is the ADK web UI that's connected to our my project agent group. Okay, if I use a valid API key, then I can type to talk to the model. So if you compare that legacy web app building process You will need a fast API server. You will need a WebSocket handlers if you use audio communication, and you need to encoding and decoding audio like we have done for the previous projects if you watched my previous videos. So you also need to manage the session management and a custom front end with the UI and CSS design. So that is ADK web command give you all. So now let's get into the code simply to see how our live document search application implemented, which includes a RAG system and also the live voice interaction. So I built all the agents under the RAG agent, and you will see there is a standard agent py file. We're including 3 agents we designed for our system. Let's break down each agent's role. So first agent, we call it file manager agent, which handles the file uploads. So when the UI's upload button is used, file comes in as a inline data in message paths. This agent has 2 tools. One is the list file tool, which is used to check what is available in its storage, and the other is index file tool, which is to upload to the file search store. It should not use the live model. It should be using the standard Gemini 2.5 Flash model. And we have instruction that guide the model to stick on the task to do the file related operation only. And the second agent called search assistant agent, which is our key agent that using the Gemini 2.5 Flash native audio preview model to do the live audio interaction to respond to the queries of the file search store. And it has the search tool, which is used to call to do the semantic search into vector store, which is managed by the Gemini API for file search tools. And last one is root agent, which using a custom base agent called the RAG orchestrator that detects the file uploads and route to the file management agent to the question to search assistant that need to answer voice queries. No tools by itself, it's just the coordination logics. So here is the system workflow diagram, which shows how these agents coordinate with each other. So from the ADK web UI, you have text input, you have microphone input, and upload button, and send. Okay, so when anything is coming, the RAG orchestrator, which is our custom base agent, is working for filter and orchestrator which agent should be interacted. So when there is a file, it will go to the file upload blocks managed by the file manage agent, working asynchronously with the tool list files and index files to do the pure file search, which is not search for the content, it's just a search document existence. And when there is a text question, it will go to the search assistant and use the tool search docs to search the existing documents for query, for retrieval, for citations. And if there is a voice input, it will check the uploads in session. If there's an uploads session, it will call file manager to do the list and the index. After that, it will do the search assistant in lifestyle to do the semantic search in the current store. And all these tools will become a test response by the AI back to the user. So once the file uploaded, it will show converted file name. If the question is answered, it will say based on the exact what document, the answer is blah, 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 and give the source of this answer. Now let's see how these implemented one by one. The first one is the orchestrator implementation in the orchestrator py file. So we define a new class called rag orchestrator inherited from the base agent, which is used only for the custom agent to do the custom actions that's out of the pre-built functionality. So the key here is the inline data, which checks the last message for the file uploads messages or the keywords like upload or index, which delivered by the UI in front end. If found, it will route to the file manager to do file stuff. Otherwise, it will route to the search assistant to do the direct semantic search on the existing document. The entire UI integration is automatically done. So when a user clicks the upload button and selects a PDF or other type of file, it appears as a part of inline data with the file's bytes and MIME type. The orchestrator detects it and routes accordingly. That's why we should need a custom agent to do this, because the original agent cannot do these logic stuff. Alright, so now let's connect everything to Gemini file search. We need 3 tools: list files, index files, and search documents. So I'll open file upload handler py file to see these functions. So first we see the list uploaded files. This tool checks what files are available for indexing. Here we check the session history. So why are we doing that? Because the file uploaded via the UI button arrive as inline data, if you remember, which is not automatically saved as artifacts. So we need to extract them from the session events and list them. So second, we need the index uploaded file, which is the tool that uploads the file to the file search indexing storage. Here we create a file search store by call the Gemini file search API. When the first uploading happens, we check the duplicates using the file store config JSON file here and put the upload operation until completion. In this JSON file, we record the file operation history. Now we go to the file search tool py file to see the final search document tool definition, which is handling the queries to the file search store by using the Gemini API of file search tools. Here you see the model we use is a Gemini 2.5 Flash, not the live model, because we want it to as accurate as enough to do the file search response generation. When the handler function is done, the tool is done. Now we can create the agent to use the search tool. So here in the definition of this agent, because it will answered by voice, so we asked in the instruction that use a natural friendly speaking style to talk to the users, and we gave the example how to answer and what need to be included, and also ask the model strictly to call this tool to answer users' question when it's related to the document. So basically now the text interaction about uploaded document is working. So because we are going to implement not just a text model RAG system, but also a voice interacted RAG system, so we have to implement the voice interaction based on the custom agent as well. So let's look back to the orchestrator file to find that we have a overridden run live implement function that is exactly defined for the live voice mode. Because originally the orchestrator only has run async implementation, which handles the text mode only. So the voice mode requires run live implementation overridden. So now the orchestration logic becomes if an uploads event detected, it will run file manage in async text mode to index them, then run the search assistant in live model to answer the questions. So that's all for this backend code. Definitely, you don't have to manage a lot of workflow stuff. You only need to take care of the agents and tools and their operations. So again, the entire source code you can find in my GitHub repository to do your experiments or customization. I think the ADK platform with the web UI system has quite much potential to be extended for the actual agents projects. That's all for today. If you have further questions or ideas, please drop them in the comments below. Thanks for watching. I'll see you in the next video.